Alright, let's look at the homework 15.5, problem number 4. Alright, so let's work on this problem. Alright, so boundary lamina consists of two semicircles. So let's sketch the picture. So here is the x-axis, and here is the y-axis. Alright, so we have two semicircles. First one is radius is going to be 1. So it's going to go through 1 here, and here's going to be 1. So semicircle would look like this. Alright, and the other one, radius is going to be 5, right? Because r squared is 25. So it's going to hit -5 here and positive 5 there. Right? Then you have a larger semicircle. Alright, so it looks kind of like that. Alright, then also the part of the x-axis. So we're talking about this region right here. Alright, so what we want to do is we want to find the center of mass of this metal plate or whatever. Alright, so let's do that. And in this case, x bar is going to, we can probably use the symmetry because it's a symmetric about the y-axis, right? And the density is proportional to its distance from the origin. So everything is symmetric. So what we can probably say, the x bar is going to be 0, right? So y bar is the more challenging one, right? So let's find the moments about the x-axis. Right? So this is going to be a double integral over this region. I'm going to call it D or something like that. Alright, then you're going to have x. Actually, we're going to do a y, sorry. Y. Then rho of x comma y. With respect to, area element, right? Right, but let's say it says that, let's see, the density at any point is inversely proportional to its distance from the origin, right? So we know that the rho of x comma y is going to be proportional, so it's k. So inversely proportional, so it's going to be over. And distance from the origin is a square root of x squared plus y squared. Alright, so if you write this in polar coordinates, this is what we're going to get. So we have a double integral. Right, so y is going to be r sine of theta. Right, then you're going to have density is k over, right, x squared plus y squared is r squared with the square root, so that's going to be just r, right? And then area element is going to be always r dr d theta. Alright, so it looks like r is going to start from 1 to 5, so here's a 1 to 5. And to cover the entire region, so theta is going to start from 0. Maybe I should write that. Right, theta is going to start from 0. Then go all the way to the other side. So it's going to be theta is going to be equal to pi. So it goes from 0 to pi. Right? Then we can cancel r on top and r on the bottom. And we're going to just put k outside. So k would be outside here, right? Then you have an integral. We're going to separate them. I'm going to do the integral with respect to r. So it's a 1 to 5. And there's r. Then you have a dr, right? Multiply by integral 0 to pi. You would have a sine of theta. And then with respect to theta. Right? So if you compute that, you're going to get, right? So antiderivative of r would be r squared over 2. Then going from 1 to 5. And this antiderivative sine of theta is negative cosine of theta. And this goes from 0 to pi, right? So this is going to be equal to, right, here's k, right? Then you plug in 5 here, so you're going to get 5 squared, so 25 over 2, and then plug in 1, so it's a 1 over 2, right? So this is going to be 24 over 2, so it's going to be equal to 12, right? And then here, plug in pi. Cosine of pi is -1 with the negative sign positive, minus with the negative sign, and cosine of 0 is 1. So it's going to be 2. So this is going to be equal to 2 times 12, so 24k. All right. Then we still have to find the mass. So mass m is going to be, right, double integral, right? Then we're going to have r dr d theta, and the bounds are exactly the same, 1 to 5 and 0 to pi. But here we have to remember that, let's see, the density is k over r. So we put the k over r. Then we can just cancel r and r here. So what you get is going to be, so I'm going to actually go down here, right? K is just a number. Antiderivative of theta is going to be theta, going from 0 to pi, times antiderivative of 1 would be r, then going from 1 to 5. So this is going to be k times pi times 5 minus 1. So this is going to be 4k pi. Alright, so if you want to find the y bar, all you have to do is find the moment about the x-axis, divide by the mass m. So which got we got 24k and a minus, and we have 4k pi. So we can cancel k and k, and then we can cancel 4 and 6, right? So this is going to be equal to 6 over pi, right? So let's type it in. So what we got is, alright, x bar is going to be 0, but the y bar is going to be 6 over pi. Alright, so let's check the answer. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.